We're going to switch gears today and do something a little bit crazy, and it's called indirect proof. What is an indirect proof? An indirect proof is one in which you prove that a statement is true by first assuming that the opposite of the statement is true. If this assumption leads to an impossibility or a counterexample, then you have proved the original statement is true. And you probably use this a lot when you argue with people and you just didn't know it. But anyway, here's how it goes. If you want to write an indirect proof, the first thing you got to do, state as a temporary assumption the opposite of what you're trying to prove. All right, and then you got to show that the temporary assumption leads to a contradiction. I think I said counterexample a minute ago. I meant contradiction. Or, just this assumption is going to lead you down a path that you discover, this can't possibly be because of what I know about geometry and the given information. And once you get to that contradiction, then you can conclude that your assumption is false and what you're trying to prove is true. So here's how it goes. All I have in this lesson is pretty short, because you're going to have a quiz next class, and after you look at this, the quiz will not cover indirect proof, so you'll have plenty of time to review for your quiz too. We'll just do a couple of examples here. All right, and we do these in paragraph form, not two-column form, and I'm going to admit I'm a little bit lax with the indirect proof. You got to basically know how it works, but you don't necessarily. I'm just not as picky as I am about two-column proofs. We'll see. Here's how it goes. Given ABC is a right triangle, I'm going to go ahead and draw this. I like to draw my given. So ABC, so B is my right angle, so we'll call this ABC. Okay, and it says prove that ABC does not have an obtuse angle. So what do? What did I tell you to do in the first step here? Assume the opposite. So I'm always going to start, the first word in your indirect proof is always going to be assume. And what am I going to assume? I'm going to assume that I do have an obtuse angle. So I'm just going to pick assume that angle C is obtuse. Okay, so by the definition of obtuse angle, the measure of angle C is greater than 90 degrees, right? I know that because of the definition of obtuse angle. Therefore, the measure of angle B plus the measure of angle C is going to be what? It's going to be greater than 180 degrees, right? Because if the measure of angle B is 90, the measure of angle C is greater than 90, then I know that the sum of those two measures is going to be greater than 180 degrees, but I'm going to say this is impossible. So I've already found my contradiction. This is impossible because by the triangle angle sum theorem. What does the triangle angle sum theorem tell me? The measures, take the sum of the measures, the sum of the measures of the interior angles of a triangle is 180 degrees. Therefore, neither angle C nor angle A can be obtuse. and then I'll just write my proof statement, even though I've kind of just said it. That's what I was telling you about indirect proof. When you write these paragraph proofs, it's really kind of up to you how you word it. This is why I prefer two-column proofs, but to end, I'm always just going to say, let's see, therefore neither angle C nor angle A can be obtuse, and triangle ABC does not have an obtuse angle. So your first word of an indirect proof is going to be assume. You're going to assume the opposite of what you're trying to prove. Then you're going to make your statements that lead you to a contradiction, and then your last statement is going to be whatever it is you were trying to prove. All right, there's one more here. So why don't you give this one a try, and then I will put the solution up here and you can check yours against it. Pause the video and write this one for yourself. Okay, so we start off by assuming I drew my sketch so that A and C, angles A and C are my base angles, and I assume I can pick either one. I just picked angle A. Assume that angle A is a right angle. Since angle A and C are the base angles of an isosceles triangle, I know they're congruent by the base angles theorem. And you have to state that. How do you know they're congruent? Because of the base angles theorem. Okay, well, this means that angle C would also have to be a right angle if those two are congruent. And the measure of angle A and the measure, and each one of those measures would be 90 degrees. Perhaps I could have worded that a little more nicely, but anyway, you get the gist of it. If they're both right angles, both of their measures are 90 degrees. All right, if that's the case, then the sum of their measures is 180 degrees, but this is impossible by the triangle angle sum theorem that tells me that the total, the sum of the measures of all the angles is 180. That would mean the measure of angle B is 0, which is impossible. I don't have to write all that, guys. This is plenty, okay? And therefore, since I know that the sum of two angles in a triangle can't be 180 degrees, I know that neither base angle in this isosceles triangle or any isosceles triangle can be a right angle. All right? You might find some more problems in your textbook to practice on writing indirect proof, but for now I think your time would be better spent to review for your quiz. And we have one more lesson in this unit, which is inequalities in triangles, and I'll see you next time.